You drive past a construction site, and what do you see? Usually just a huge mess of dirt, right? Well, it turns out that pile of earth is one of the single biggest financial risks in the entire project. Seriously, this isn't just about digging a hole. It's a high-stakes science that can absolutely make or break a multi-million-dollar budget.
I know, it sounds a little dramatic, doesn't it? How can just moving dirt around actually bankrupt a company? Well, the answer lies in this really dangerous mix of bad math, some hidden physics, and a bunch of costs people just overlook. If you get just one of those things wrong, the consequences can be catastrophic.
And you can literally see the chain reaction right here. It starts with a simple error, right? Misjudging how much dirt is actually there. Then you hit some unforeseen risk, like solid rock you didn't know about. And maybe you forgot about disposal fees, and suddenly your profit margin just vanishes. This is the tightrope that contractors are walking on every single job.
Okay, so at its very core, earthworks really boil down to just two simple actions. You either cut, which is just a fancy way of saying digging out and removing material, or you fill, which means, you guessed it, adding material to build up a site. Sounds simple, but the real challenge, and where all the financial risk is hiding, is in how you measure these two things.
Right, so this is where the financial traps are laid. Underestimating how much dirt you have to haul away? That's the classic mistake. Forgetting that getting rid of that dirt isn't free. You've got landfill taxes, disposal fees, that's another one. But the real nightmare scenario? That's when you start digging and hit unexpected rock or groundwater. Your excavation costs just went through the absolute roof.
So this brings us to the core scientific puzzle that the entire financial equation is built on. You'd think a cubic meter of dirt is, well, a cubic meter of dirt. But, as we were about to see, that's a dangerously wrong assumption to make in this business.
To get any of this right, it all has to start here, with something called bank volume. This is the volume of the soil as it sits in the ground, totally undisturbed, perfectly compacted by nature over thousands of years. You have to think of this as the source of truth. It's the baseline. Every single other calculation is going to be based on this number.
And now for the twist. The second you dig that soil up, it fluffs up, it expands. This is called bulkage or swell. The analogy is perfect. It's like popcorn. The volume just gets bigger. Then on the flip side, when you take loose dirt and pack it down to build a foundation, it compresses. That's shrinkage. You're trying to pack more stuff into a smaller space, just like when you're stuffing an overpacked suitcase. These two opposing forces, this is where the money is either won or lost.
And this is where the numbers get absolutely wild. Just look at this table. Sand and gravel, yeah, they don't swell that much. But look at clay. It can expand by up to 40%. Now think about what that means. For every 100 truckloads you budgeted to haul away, you suddenly need to find and pay for another 40. That is a massive, unplanned expense.
But the most extreme case, by far, is blasted rock. It can swell by a staggering 75%. You're talking almost double the volume you have to get rid of? Can you imagine miscalculating that on a major project? That's not just an error, that is a budget-destroying mistake right there.
Okay, so let's look at the other side of the coin, shrinkage. When you're filling a hole, you have to account for how much that material is going to compress. This is called your wastage allowance. You actually have to order more than you think you need because, as you can see here, a pretty big percentage of it is basically going to disappear as it gets compacted down. And with something like imported hardcore, that wastage can be up to 50%. Let's be really clear about what that means. To fill a 1 cubic meter hole with compacted hardcore, you have to buy and transport 1.5 cubic meters of the loose stuff. You are literally paying for 50% more material than the final volume you actually end up with. Insane.
So, okay, with all this tricky physics going on, how in the world do professionals measure what's underground and make accurate predictions? Well, they can't just guess. They have a whole specialized toolkit of methods to turn this invisible problem into hard, reliable numbers.
And the two main weapons in their arsenal are the grid method and the cross-section method. Which one they use really just depends on the shape of the job. For big, wide-open sites, they'll use the grid method. But for those long, skinny projects like roads or pipelines, they'll switch over to the cross-section method.
So how does this grid method work? Well, imagine laying a giant checkerboard over the entire construction site. Surveyors then go to every single intersection on that board and measure exactly how deep they need to dig. They use some clever math with weighting factors to get an average depth for the whole site. Multiply that average depth by the total area, and boom, you have your bank volume.
Now, for something long and thin, like a road, they use the cross-section method. So instead of a grid, they take these slices of the project at perfectly equal intervals. They measure the area of each slice, and then they use this really powerful formula called Simpson's rule to basically connect the dots and calculate the total volume. The key here, though, is precision. You need an odd number of slices, and they have to be spaced exactly the same distance apart for the math to work out right.
Okay, so we've covered the physics, we've covered the measurement techniques. Now for the most critical part, turning all of that data into a price. This is where the work of a quantity surveyor directly impacts the financial health of the entire project.
In this quote, this really gets to the heart of it all. You don't just pull a price out of thin air. You build it from the ground up, from what they call first principles. That means you are calculating the exact cost of the machinery per hour, the labor per hour, the materials, and then you divide all that by how much work you can get done in that hour. It's an incredibly detailed process.
So, let's take permanent work, like removing topsoil. The digging part is priced based on its bank volume, but, and this is the part you can't forget, the charge for disposal is a totally separate line item. And that disposal rate absolutely must factor in the extra cost of hauling away that larger bulked-up volume we talked about earlier. Miss that, and you're losing money.
And it's not just the permanent dirt that gets priced. Even temporary safety stuff, like the shoring that holds up the walls of a trench, is meticulously measured. And what's really clever is that the rate includes not just the cost to put it in, but also the cost to take it all out again later on. It's all built in.
And here's another layer of financial savvy for you. For those temporary materials, they don't charge the full price on a single job. So a piece of timber shoring can be reused 4 times before it's worn out. The contractor only applies 1/4 of its cost to this project's unit rate. It's that kind of smart accounting that keeps bids competitive.
All right, we've covered a lot of ground here, both literally and figuratively. So let's just quickly recap the most important things to remember about the hidden science of moving dirt.
Okay, here are the 4 things you have to take away from this. Number 1, accuracy is everything. It is directly tied to profit. Number 2, always account for bulkage, that swell factor when you're pricing disposal. 3, always add a wastage allowance for shrinkage when you're ordering material to fill a space. And finally, number 4, use the right measurement tool for the right job shape. Get those right and you're on your way.
So, I'll leave you with this final thought. The next time you drive past a construction site and you see all those excavators and huge piles of earth, I hope you'll see it just a little bit differently. Not just as a pile of dirt, but as this dynamic, high-stakes financial equation that's being solved right there, in real time.